6, we have the circuit shown to the right. And I've put the resistances and the voltages on there already. Please notice that one point of the circuit is grounded, so V equals 0 there. Question is, what's the size and direction of the currents through each of the resistors and the electric potential at point P? So to solve this, I'm going to go ahead and do a little bit of guessing. We're going to use Kirchhoff's rules. I'm going to guess that the current through R1 is going, or R2 is going to the right. I'm going to call it I1. And I'm going to guess that the current through R3 is going to the left. I'm going to call that I2. I'm assuming both the batteries are going to force current around in the direction that they're trying to push the EMF. And then for R1, I could list that as going downward as I3. But using the junction rule, I simply know that the current going into the junction up here has to combine together and go down here. So instead of a separate variable, I'm just going to say this is the sum of I1 plus I2. Once I have that, I can go ahead and start writing my circuit, or I'm going to work around this circuit clockwise and write my equation for it. So for loop 1, the voltage drop across this top resistor 200 times I1 plus the voltage drop across R1 100 times the sum of those two voltages must equal the source of EMF, which is 6. And since I'm going through all the resistors in the direction that I guess the current, and I'm going through the battery in the direction of EMF, everything is positive. Now I can reduce that down a little bit by combining terms down to 300 I1 plus 100 I2 is equal to 6. Now I'm going to do the same thing for the other one, but this time working around counterclockwise just makes it a little bit nicer since all the currents are drawn that way already. In this case, going for the top resistor, 300 times I2 plus 100 times the sum of I1 plus I2 equals the source of EMF in that loop, which is 12. Again, just simplifying that a little bit, 100 I1 plus 400 I2 is equal to 12. At this point, I'm going to grab my TI Inspire and just do a linear solve of those two. I've created the variables I1 and I2 just to make it easier on myself. And so this number right down here is I1, and this number over here is I2. Notice that both these are positive, which means I guessed well. So the currents are in the direction that I guessed. And now we actually have to do the number solutions yet on this one. So A and B asks, what's the direction of the current through R1? R1, since the current going through, it's a sum of both of these currents down here. Just adding those together, I get about 0.082 amps, and of course it's going downward. Next one we're doing is resistance 2, and that is just going to be, for this one here, just the current I1, so 0.0109 amps, and that's going to the right. For R3 over here, that's just going to be going to the left, and the current is now I2, 0.0273 to 3 sig figs. And then finally, what's the voltage at point A? Well, we know, of course, the voltage here is going to be 0 volts. Here it's going to be 0 volts. Up here, 12 volts after we go for the battery. And then we need to figure out, hey, how much is the voltage going to drop going across this resistor? Well, we know that's equal to I times R. And I've already written it down below. I jumped ahead a little bit. So the current through that is this. Whoops, I should have ended parentheses there. The resistance is 300. And it gives us about 8.18 volts. So taking 12 and subtracting the 8.18 voltage drop across this resistor, what's the voltage at point A? Well, it should be about 3.82 volts. Please realize I could have also worked a bunch of different ways through this one. I could have just taken the total current through this resistor here times this resistance 100. And yes, this times 100, also approximately the same. Actually, it is the same answer. I also could have worked around this loop, 0 volts, 6 volts, figure out the voltage drop here, and I would have ended up with the same answer. So there's multiple ways of getting there. I hope that this helps.